Now, let us solve this problem similar to our example number 1, but this time, hindi na siya symmetrical kasi 4 meters siya galing kay A and 6 meters siya galing kay B. So, yung 10 kilonewton, hindi siya directly mahahati equally between A and B. So, mapapansin natin, mas malapit siya kay A, ibig sabihin, mas malaki yung force na bubuhatin ni A compare kay B. So, dito sa A, we have a roller support. Ibig sabihin, meron tayong support along vertical axis lang and meron tayong degree of freedom along X. And dito naman sa B, meron tayong since hinge support siya, ibig sabihin, meron tayong support sa vertical axis and as well as sa horizontal axis. And since wala naman tayong horizontal load, automatic, RBX, we know that RBX is equals to 0. But if we want to make sure kung tama ba yung assumption natin or na si RBX equals to 0, we can use equations of equilibrium to determine the unknown values or unknown dito sa forces sa ating figure. So, meron tayong tatlong unknown, RAY, RBY, and RBX. So, since tatlo yung unknown natin, ibig sabihin, kailangan na tatlo din yung equations na gagamitin natin or tatlo din yung equation na kakailanganin natin para ma-solve si RAY, RBY, and RBX. Sisimulan natin kay summation of all forces along x-axis equals to 0 to the right being positive. So, since wala tayong ibang horizontal support, ang meron lang dyan is RBX. So, automatic, RBX is equals to 0. Diba? Next, dalawa na lang yung magiging unknown natin kasi meron na tayong RBX, si RAY, and RBY. Anong equations or anong dalawang equation na lang pwede natin magamit? Si summation of forces along y-axis equals to 0 and we know that the moment at A, pag simply supported, we know that the moment at supports are 0. So, moment mo sa A equals to 0 and the moment at B equals to 0. So, we can sum up all moments at A or B which is equal to 0. So, lahat ng moment na i-add natin, papunta kay A and papunta kay B, dapat equal silang lahat kay 0. So, moment tayo kay B. Kunyari, so summation of all moment at B, clockwise rotation being positive. So, magsisimula tayo dito kay RAY. So, RAY, papunta kay B, moment siya kay B. So, ano yung rotation niya? Clockwise ba or counterclockwise? So, papunta kay B, clockwise yung rotation ni RAY, clockwise. So, RAY, sabihin positive. So, positive RAY times the moment arm na 4 plus 6 which is equal to 10. And, dito naman sa 10 kilonewton load. So, sa 10 kilonewton kilonewton na downward force. So, since downward siya, ibig sabihin papunta kay B, counterclockwise yung kanyang magiging rotation. So, instead of plus, magiging minus 10 times yung moment arm which is equal to 6 meters. So, equate natin yan equal to 0 kasi wala na tayong ibang force dyan. Diba? Si RBY, yung moment arm niya kay B is 0. So, hindi na siya mani-neglect na siya. So, therefore, we can solve for RAY. Diba? RAY is equals to positive 6 kilonewton. So, since positive siya, ibig sabihin, tama yung assumption natin na 6 kilonewton yung bubuhatin ni A upward, in upward direction. Since meron na tayong RAY, so we can solve for RBY using summation of vertical forces equal to 0. Para magiging equilibrium sila, di ba? Equate natin, if i-add natin lahat ng forces, dapat balance or magiging 0. So, summation of all forces along y-axis, upward being positive. So, meron tayong RAY plus RBY minus 10 is equals to 0. So, i-add natin lahat ng forces along vertical axis, dapat mag-equate sila lahat kay 0. So, ayan. So, therefore, 6 kilonewton may plus RBY minus 10 equals to 0, makukuha natin si RBY equals to positive 4 kilonewton. So, since positive 4, yung nakuha natin, since positive, ibig sabihin, tama yung assumption na yung direction ni RBY is upward. Okay? So, meron na tayong force along y-axis kay B. Or may reaction na tayo kay B along y-axis. So, since may mga forces o may mga reaction na tayo, nakuha natin lahat ng reaction, lahat ng forces, we can start drawing the shear diagram. So, draw tayo ng line dito para ma-align yung drawing natin sa ating figure. Ayan, so, dito sa A, magsisimula tayo sa 0. Ito yung magiging 0 natin, o yung reference natin. Dito sa A, meron tayong upward force na 6 kilonewton. Sabihin, from 0, meron tayong upward force na 6. So, positive 6 kilonewton. And since wala tayong ibang forces dito, so constant lang na yung shear dito banda is 6 kilonewton papunta dito. Sabihin, 1 meter from A, 2 meters from A, 3 meters from A, 3.5 meters from A, lahat yan sila 6 kilonewton yung shear. And pagdating naman dito sa 4 meters, meron tayong downward force na 10 kilonewton. So, 10 kilonewton, so positive 6 minus 10 kasi downward, diba? So, negative 6 minus 10 is negative 4 kilonewton. And wala tayong ibang load dito sa taas, ibig sabihin, constant lang na yung shear mula dito papunta dito equals to negative 4 kilonewton. And pagdating naman sa B, meron tayong upward force na 4 kilonewton. So, negative 4 plus 4 equal to 0. So, ma-close natin yung shear diagram. So, yung shear at B, diba? Shear at B is equals to 4. Shear at here equals to 4. Shear at here equals to 4. Okay? So, meron na tayong shear diagram. Now, draw na natin si moment diagram. So, si moment diagram, draw tayo ng line dito, draw tayo ng line, and draw tayo ng line dito. Draw natin si moment diagram. Paano natin makasi moment diagram? Diba, moment is the area of the shear. Tama? Yung moment natin dito is the area of the shear. Paano? So, sa area 1, kukunin mo natin si area 1. So, for areas, area 1 is, yung shear natin dito is rectangular. So, area ng rectangle is height times base, tama? Or base times height. So, area 1 is simply positive 6 kilonewton times 4 meters or equal to positive 24 kilonewton meter. So, galing dito, and we know that the moment at A is equal to 0. Tama? Walang zero din yung displacement natin dyan. So, galing tayo dito kay A, dito sa left side, sabihin, sa 0 tayo magsa-start, and papunta dito, aakyat tayo kasi positive 24, aakyat tayo ng positive 24 kilonewton. Kasi constant yung shear natin dito, ibig sabihin, linear yung, or the same lang yung slope natin dito. Linear. Kasi, kasi, di ba, yung moment natin, habang papalayo siya ng papalayo, papalaki na ng papalaki yung ating moment. So, kung mag-cut ka dyan, ito yung magiging moment niya. Mag-cut ka dyan, ito yung magiging moment niya. If you want to determine the moment here, or any point at here, you can use ratio and proportion. Kasi, linear lang yung ating line. Dito, yung diagram natin. Next, galing tayo dito, kukunin natin yung area 2. So, the same with area 1, sa area 2 is base times height lang, rectangular. So, negative 4 or height times base, negative 4 times yung base natin na 6 meters. So, area 2 is equals to negative 24 kilonewton meter. So, galing ka dito sa positive 24 minus 24 kasi negative. So, 24 minus 24 is equal to 0. So, na-prove niya na 0 talaga yung moment at B. Okay? Naka 0 talaga yung moment at B.